Hey everybody, this is Matt Morgan. In this lesson we're going to talk about acid-base hydrolysis equilibria and work Wiley problem 13-082. We'll define what hydrolysis is, talk about acids and bases reacting with water, and then go over all the parts of problem 13-082. Section 13-7 of the text says that hydrolysis is reactions of cations as an acid, anion as a base. Remember, cations are positively charged, anions are negatively charged. The other reactant in the hydrolysis reaction, as the name implies, is water. Water's really cool because it can act either as an acid or a base depending on the other chemical it's paired with. So think of water as a chemical chameleon. Acids and bases are all about H+ ions. Acids give them up and bases accept them. Acids will donate an H+ ion to water, making hydronium. Bases will accept an H+ from water. There's our acid. It donates the H+ ion. Bases, on the other hand, will accept an H+ from water. Now, what does that give us? Water becomes hydronium, H3O+, when it accepts an H+. While water becomes OH- if it donates H+ to a base. These are two very important concepts. So as we go through the examples, we'll be watching for reactants to be gaining or losing H+ ions. So watch for a change in the number of hydrogens, but more importantly, watch for a change in the charge. When an acid donates H+ or a base accepts, the charge will change from reactant to product. If an acid loses an H+, it becomes more negative. If a base gains an H+, it becomes more positive. Let's look at a couple examples. We have phosphoric acid. It will donate an H+ to water, giving us hydronium, but then our other product is the dihydrogen phosphate. Notice that it has one less hydrogen and it has a negative charge. It started out neutral, then when it donates an H+, it has a negative charge. Let's look at a base. For example, the F-, the fluoride ion. It will accept an H+ from water. The water becomes hydroxide, OH-, and our other product is hydrogen fluoride, or hydrofluoric acid if it's in water. It has one more hydrogen and it is neutral. Let's now look at Wiley problem 13-082. In the first example problem, we have cyanide plus water going to HCN plus something else. The cyanide ion became HCN, and to do that, it gained an H+ from water. That tells us that cyanide is a base. Water lost an H+, so the other product has to be hydroxide. The reaction we want to write, Cn- plus water in equilibrium with HCN plus hydroxide. Be sure to type the entire reaction in the answer box, and we need to use a double arrow because Cn- is a weak base. The next example is ammonium plus water gives us something plus hydronium. The given product is hydronium, so that tells us that ammonium, an H4+, is an acid, and water accepted an H+ ion from it. When ammonium loses the H+, the resulting molecule is ammonia, NH3. So we need to account for losing both the hydrogen and the positive charge. The answer that we want to type is NH4 plus water in equilibrium with NH3 and hydronium. The first two examples, straightforward. You need to know how to do problems like that. This homework problem also has two other examples. They are good for practice. They are complex, probably go beyond what you might see on an assessment. However, don't just skip them. They do include some valuable concepts that you can apply in the assessment and in your future chemistry career. So let's go over those last two, and we'll be sure to focus on the takeaways from those problems. We've got H3BO3 plus water gives us a boron, 4 hydroxides, a negative charge, and another product. There's been a lot of bond rearrangement here. Now our key to solving this is to realize that our reactant, H3BO3, starts out neutral, and then as a product it has a negative charge. Based on what we've learned before, that tells us that the H3BO3 has donated an H+ ion to start neutral and go negative. The name for H3BO3 is boric acid. Had they told us that in the problem, that would have been a very good clue and told us that it's probably going to donate an H+. So if it donated an H+ to water, our missing product is hydronium, H3O+. There's our reaction, but we're not done yet because it's not balanced. If we count the hydrogens and the oxygens on the left and right, they're not going to be equal. This tetrahydroxyborate, the BOH4-, has an extra oxygen and hydrogen. So what we have to do to balance our equation, we have to have 2 water molecules on the reactant side. So the reaction we want to type in is H3BO3 plus 2 waters in equilibrium with the tetrahydroxyborate ion and hydronium. So do you need to know this reaction? Don't panic. The answer is you don't. But what you do need to know is that this H3BO3 starts out neutral and it becomes negative. And the only way it does that is by donating an H+ ion. Let's look at our final example. It looks complicated, but let's stick to our acid-base fundamentals and we'll be able to solve it. We have an aluminum hexaaqua complex ion plus water goes to aluminum with 5 waters and an OH and some other product. Boy, a lot of atoms there, easy to get lost, but let's focus on the charges. The reactant has a +3 charge. When it's a product, it has a +2 charge. If the reactant has lost a positive charge, it must have given up an H+ ion. Okay, it's an acid. We combine that with water, it donates an H+. Hydronium, that's our missing product. And then what we have left, 5 waters, an OH, and a +2 charge. Let's count the hydrogens on the left and right side. On the left side, I've got 6 waters, each having 2 hydrogens, 12 hydrogens. In our product molecule, there are only 11. There's 1 less hydrogen and a +2 charge, so it has lost a plus charge. If the reactant has lost a positive charge, it must have given up an H+ ion. We counted the hydrogens. We go from 12 to 11, so it's definitely lost an H+ ion. Our other product is hydronium. We saw that. And so there is our reaction. Now, if you've tried to put this into Wiley, you might have had some difficulty. It definitely stretches the limits of the Wiley equation editor. So there's a couple of tricks to allow you to put this answer into Wiley and get the green correct frame. So let's look at some screenshots as we go through this. Okay, we put in our aluminum, we put in our water. The cursor's inside the parentheses. Don't type your 6 yet. Press the right arrow key. That will move the cursor outside the parentheses. Now type your 6. Use your drop down to add your +3 charge. Okay, the cursor is next to the 3+ and it's small. You won't be able to type a plus to get your water in. Once again, your right arrow key will make the cursor big and we'll put it next to the first molecule. You can now type your plus and your H2O to get your reactants. Be sure to type a double-headed arrow or click on the double-headed arrow in your equation editor. Now we'll start typing our products. We've got our aluminum, we've got water. The cursor, once again, is inside the parentheses. Don't type your 5. Right arrow key. Now type the 5 when the cursor is outside. Okay, here's where it gets strange. Don't type another parentheses yet. If you do, the water that you've typed in will disappear. We don't want that. With the cursor next to the 5, just type a letter, and that letter will appear and your water won't disappear. Then type your opening parentheses. That extra letter, whatever it is, we're going to get rid of it. But for now, this will allow us to type our OH. Type the OH inside the parentheses, add your +2 charge. Then move the cursor to delete that extra letter. Finally, type your plus and your hydronium and submit. That will get you your green frame. That was quite a process. So it's easy to get lost in the formatting and forget the chemistry. Remember, the reason we're doing this problem is to learn acid-base hydrolysis. What we want to take away is the reactant's charge changes from +3 to +2, and it has one less hydrogen. It is an acid. It donates an H+ to water. Our other product is hydronium. That's your takeaway. So, no math involved in this, which is good, but you do have to know the concepts. Practice the Wiley problems, and of course contact your course mentors if you have any questions. There's our group inbox email, and of course you can contact individual course mentors from your course of study.